I'm Kyle Hubbard, and this is my problem on energy. So the problem is this: a 90 kg bike rider starts at rest on the top of a 500-meter hill at a 5-degree incline. The average friction force throughout the ride is 60 newtons. Find the velocity of the biker at the bottom of the hill. And B is another hill with a 10-degree incline, starts at the bottom. How far will he make it up the hill without pedaling? Assume there is no friction on the uphill part. So over here is the start of the problem. This is how we're going to start the problem. We're going to start off by finding height because it is needed. It is key to this problem. So we're going to use trigonometric functions to find that. So we're going to use the sine of 5 degrees and the hypotenuse h equals 500 meters times the sine of 5 degrees, and this will give us the height, which is 43.6 meters. Then next we're going to start off by write out the equation for energy. Now this is an open system. And what an open system means is there is an external force acting on the object that we're analyzing, which means there is a loss or gain of energy throughout the whole problem. In this case, it's going to be a loss of energy since there's friction, and that's going to be taken away. So the problem is going to be U initial. U initial is gravitational potential energy, plus K initial, which is kinetic energy, plus work done by friction. Work is done by friction. And then U final plus K final. Now we're going to start with the equation for, we got to simplify this, so the equation for potential energy is mgh, and there is potential energy at the start of the problem. However, there is no kinetic energy since it is at rest, so we're going to put a 0 there. And then there is work, and there's an equation for that I will show you after. At the bottom of the hill, since there is no h stands for height. Since there's no height, that's where our coordinate axes stop. This is h equals 0 down here. That's going to be 0 for the potential energy, and kinetic energy's equation is 1/2 mv squared. So first we're going to start off finding the potential energy. We have the mass, which is 90 kg. This is potential energy. We're going to plug them in. We have the mass, 90 kg, times g, which is the acceleration due to gravity, fundamentally known as 9.8 meters per second, times h, which we found in the previous problem, 43.6 meters. And this comes out to 38. U initial is going to equal 38,435.7 joules. Sorry, my handwriting is a little messy, but work done due to friction. So work, the equation is work is equal to the dot product of force times distance, since they are both vectors, times cosine theta. And cosine theta is going to be equal, cosine theta is going to be equal to 180, which equals -1. 180 because the friction force is acting directly backwards that way, so in a straight line backwards that way. And that's going to equal to -1, so we're going to have it equals 60 newtons times 500 meters times -1. And that means the work is equal to 30,000 joules. Negative 30,000 joules. So you're going to put this into the equation over here, and that'll help us solve for our V final over here. Now, to make this easier, I'm going to rearrange it, also simplify this, so it's going to be 8,435.7 joules. It's equal to 1/2 is equal to 1/2 mv squared. And if you rearrange this, you will get 2 times 8,435.7 joules over m is equal to v squared. Then you take the square root of that to isolate the v. Over m. And this all comes out to v final is equal to 13.7 meters per second. The incline is slightly changed. So we're going to basically do the same problem but in reverse, since we already have the energy at the bottom of the hill, which is 8,000. This is equal to the energy at the bottom of the hill, 8,435.7. We can start with that. So, and in this one, the equation is going to be a little different, since I said assume there's no friction on the top. That means this is no longer an open system. That means it is a closed system now. So the problem we'll read is U initial plus K initial equals U final plus K final. And that means no energy is lost through this process. So that means the energy here has to equal the energy here. So now, since we're starting from the bottom of the hill, there's going to be no potential energy. And the kinetic energy is going to be equal to the number we saw before. So 8,435.7 joules. And then all of it's going to be potential energy. That's because we're trying to find at the point where he stops. And that's going to be the maximum height. So we're going to do mgh plus 0, because there's no, at that point he's going to be stopped and there's no kinetic energy. So now if we're going to go for we're trying to find the height, so you rearrange this, you have 8,435.7 joules over mg equals h. So now you just plug in 8,435.7 joules over 90 kg times 9.8 meters per second squared equals h. And that comes out to be h equals 9.56. So we're going to go ahead and write that over here. And then, as the beginning of the problem, we're going to use trig. So to find the distance he travels up the hill. So we're going to do x. We're going to define the distance as x. And we're going to do x is equal to 9.56 over sine of 10 degrees. And our final distance is going to equal to 55.08 meters.